Hello, this is Kali Gonzalez with MLC CAD Systems. Thank you for joining me for this video. I'm going to be covering the solution for the CSWP Advanced exam for Weldments. Again, if you have not actually gone through the sample exam for Weldments, I recommend that you do so before you view the actual solution. If you view the solution and then take the test, it actually makes the test easier because you know what's coming. You already have seen the solution. So please take it and let's go ahead and access our sample exam. I'm going to search for SOLIDWORKS certifications inside of a web browser. One of the first items that comes up is the SOLIDWORKS certification program. This website is going to give you a list of all of the different certifications and their information. So I'm going to scroll down until I find Weldments, and I'm going to click on exam information. This is going to give me more specific information about the live exam, such as the 2-hour time length, the 75% passing grade. And then here, I recommend that you do take a close look about the specific features that they provide in this list. You are expected to know this information, and all of this is fair game for the live exam. I specifically recommend that you become comfortable with creating your own custom weldment profiles and 3D sketching. Both of those are most likely going to be on the live test, and there's a couple gotchas in there that we'll talk about even on the sample exam. Once we're ready to click on the sample exam, this will download the zip file. Now the zip file is going to contain a SOLIDWORKS part file, which we're going to use in the sample exam, and the PDF itself, which contains information, tips and tricks, as well as specific criteria about the sample exam. If we go inside that PDF, page 7 is going to give you some advice on how to take the exam. Number 6 tells you that you should be able to get 4 out of 5 questions correct in less than 25 minutes. If you are really close to 25 or over that, I recommend to go back, make sure that you are aware of anything that could be causing additional time or really tripping you up. Now, question 1 starts on page 15. This is for question 1. We can see what looks like a custom weldment profile that we will apply to a very kind of specific shape. One thing that I want to make sure that you are aware of before you even start the sample exam or before you take the live exam is make sure that you set up your folder structure in a place where you can actually save custom weldment profiles. The generic place where SOLIDWORKS installs the basic profiles that we use is typically in a location where you could need administrative permissions or elevated permissions in order to save in that location. So I recommend that you do a test on your own computer. Make sure that you set up a weldment profile library, someplace where you know that you are going to be able to save. This can be a documents folder, C drive, it could be several different locations. The specific setting that I'm referring to is going to be under your options and then file locations. If you scroll down in this drop-down list, there's a section called Weldment Profiles. Now on my system, I do have 2 locations. The second one is actually the default, and notice this is under C Program Files. This is actually what I was referring to, where SOLIDWORKS and Windows may need elevated permissions to save there. So I created one in my training files. I know I can save items there. I can do whatever I need, and I'm not going to have any issues saving in that location. Remember that Weldments does require a specific hierarchy. So if you take a look at my system under my SOLIDWORKS training files, I manually created a Weldments folder. Inside of there, I have test profiles. And this right now is actually just a blank and empty folder location, but this is set up, ready to go. I know exactly where I'm going to save any custom profiles, and SOLIDWORKS is set up so it will automatically pull that into the drop-down lists. I recommend you set this up before you take the exam and test it out. It's going to save you a ton of time when you have to do this. This is not something you want to troubleshoot during the test. Going back into question number 1, we have our unit system, our material, decimal places. Notice that it's also giving us an A and a B value, so we can anticipate the use of global variables and equations. Now this is referencing the image above it, which has that custom weldment profile. So we know that the center is going to be located at the origin. We want to make sure that the profile has pierce points at the midpoint of each external horizontal and vertical line. And name the weldment profile and save it in the library, which we just talked about, where we know we can save it. Then we're going to apply this profile that we create to the a.sldprt from the sample file zip. We are going to align the center of the weldment profile to the 3D sketch, and then going to use end miter option to join the segments together, and we're looking for the total mass of all of the segments. So as we go into SOLIDWORKS, I'm going to go into my part_millimeter template, and we're going to actually start by creating this weldment profile. This is really just a sketch. Now I'm going to start with a center rectangle. And the reason why I'm doing this is because I can actually get the construction lines to go from corner to corner so that the rounded corners stay constrained, and I do have those as points if I need them for later questions. Once I have created my basic shape, I can create my global variables and equations in order to add those in as dimensions. So under my equations, I'm going to add global variable A, and this is going to get set to 60. From here, we can then apply global variable B and set that to a value of 90. Once created, we're ready to apply them. Remember that any global variable can be applied directly into our smart dimension and directly into that modify box. So as I create my dimension, if I hit the equal sign, this will allow me to pull in any global variable that I have created. So I'm going to set the width to be 60, and I'm also going to set the height to be 90. Again, linking it into global variable B. It's important to use global variables because if you do have to make any changes, it's going to be very fast and simple. My next step is to round out the corners, and for this I'm going to use my sketch fillet to a radius of 5. I like this because it does keep the corners constrained, which is something that will match the initial picture specifically. Now from here, I'm going to go under offset entities and add a 10mm offset to the inside. This is a great tool because it's going to kind of compensate for those corners on its own, and there's nothing else that I really have to do inside of that profile. Now to save this, you have to make sure you click on the sketch so it's active, because when you go into save as, we are going to save this as a library feature part. If your sketch is not actually selected in blue in the tree, you are not actually going to be able to utilize this as a weldment profile. So here I'm saving it into that location I showed you earlier. That's on my C drive. So again, I know this is a location I can save to. I'm not going to have any elevated or administrative permission issues. Once saved, we'll actually see that there is going to be a little L next to my sketch in my tree. And then from here, we're ready to open up Part A. This is going to be wherever you downloaded it from within your environment. So as I open up A, this is really just a simple 3D sketch. It's almost 2D, but they did use a 3D sketch to accomplish it. And I'm going to choose my structural member. Because my weldment location was already set up beforehand, I can actually start bringing this directly into my structural member. So again, choosing weldments, my test profiles, and then the weldment that I specified. From here, I can create my weldment group, and then I can actually verify that this is getting pulled into the center of this particular weldment profile, and then add the remaining members. I can change this to the mitered corner treatment and then click OK. From here, I would just need to apply my material, which is the 1060 alloy, and I can go into my Evaluate tab to access the mass properties. And as we can see, my mass is 18,101, and that does match up with the answer key provided at the end of the sample exam. So we're in really good shape going into question number 2. So question number 2, we are going to be creating our own 3-dimensional sketch. Now, something that I want to talk about here is we are provided with an isometric view, a top view, a front view, and a right view. These are orthogonal views. And so with that, you need to be extremely careful with how you dimension the angles. Because they are provided to you from an orthogonal view, you absolutely cannot create those so that they end up being angled in a 3-dimensional sketch. The sketch on this is actually deceptively tricky. So there's a couple of things I'm going to show you, but you really want to make sure that you look at these views and that you understand that these are in orthogonal views. I'll explain this a little bit after we actually create this sketch. So this is wanting us to create that shape. Now all of the lowest elements are on the XZ plane, which is the top plane. And then we want to make sure that the origin is going to be in the same place, especially if they do ask you any center of mass measurements in later questions. Once completed, we want to measure the total length of all of those sketch segments. So I'm going to create a new sketch. Now the first thing that I'm going to do is I'm going to actually do a series of reference sketches, and I'm actually going to create a couple of planes. This may seem overly complicated as I start on it, but we get an exact answer, and I'll explain a little bit more as to why I'm doing this once we get there. But for now, I'm actually on the front plane, and I'm grabbing just some generic reference dimensions. The reason why I'm doing this is because I want to specify what this 100 angle is going to be. Again, this is in a pure front orthogonal view, so I want to make sure that I'm capturing the correct angle. These lines are going to be the basis for my planes in just a couple of moments. I'm also going to add some construction geometry to the right plane as well, or to the right orientation. So I'm going to create a sketch on the right plane. Now I recommend that you snap back into isometric for this because you want to make sure the orientation is going to be correct. And what I'm doing here now is I'm looking for my yellow horizontal symbol. And this is going to be 1000. Again, this is just setting up some reference geometry for myself and establishing a lot of the scaling. Once you have that initial line, we can snap this into a normal orientation. Again, I'm directly on the right plane, so I know that my sketch angles are going to be exactly as they're specified in the drawing, which were in those orthogonal views. I'm just saving myself some time. I'm going to actually mirror this left line over to the other side. They are going to be symmetrical, and we'll close this up as well. So it's going to make sure that the line on the right portion is the same as the left, and it's going to have that 100-degree angle. So once we have these sketches with the angles established, the next thing that I'm going to do is create a series of planes. Now these planes I'm going to use for sketch relations in my 3D sketch, which I'm going to create. So I'm just really doing some setup work right now. So I'm going to create my plane. This is going to be an offset from the right plane and going through this particular line. So that's actually going to be a plane that is angled basically at that 100 degrees that we specified. So the same thing, I'm going to do an offset from the front plane, which is also going to go through this other angled line perpendicular to it. So again, I have another angled plane. And I'm going to do the third one on the opposite side. So that again, you can see I'm utilizing those sketch lines in order to create these planes. Now if I expand these planes out, you can actually see kind of the basic shape of the part. Again, the reason why I'm creating these is so that I can use them for sketch relations a little bit later. So I have them, they're ready to go, but just to simplify my graphics area, I am going to hide them. We will re-show them in just a couple of moments once we get our 3D sketch going. So inside of my sketch, they did tell us that the bottom is going to be essentially on the top plane. So I'm actually using a sketch plane. This is something you can use in three-dimensional sketches when you have something that can be accomplished using traditional 2D sketch methods. So it's almost like a 2D sketch inside of a 3D sketch. It's just being constrained to the specific plane where you see the grid. But as you can tell, this actually makes this very simple for me to start creating this basic geometry. And this feels very close to a traditional two-dimensional sketch. So I'm still adding my dimensions in. So this is going to be 1000. Now, once you are completed with this, you're not done with the sketch, you're just done with that sketch plane. So I'm going to make sure I add in my tangent and then just double click out in space. That kind of deactivates that plane itself. Now I want to do an offset off of that sketch plane. This is going to be that 700 millimeters where the top portion is going to be. So again, do this in isometric. Make sure that you know that the offset is going up instead of down. And at this point, I'm just going to create a generic shape of this. I don't really know what the offsets are right now, but what I do know is that the center of this arc is also going to be 1700, and that's because the centers are going to line up in the end. Again, double click in space kind of deactivates that sketch plane. And then I'm going to use my line tool. I'm still inside my 3D sketch just to grab those lines at the end. Now here is where I'm going to start showing my planes. So I'm going to use these planes. I'm going to grab this line in orange, and then I'm going to do an make on plane sketch relation. The reason why I'm doing this is because I'm constraining these lines to those angled planes. This is to make sure that those angles are going to be correct. Again, yes, this is actually one method that you can utilize. It's a very robust method because really if I have to make changes, I can make changes in those easy two-dimensional sketches that I created, and all of these changes will propagate. I'll finish this up by adding my remaining lines, and it does look like I missed a tangent sketch relation, so I want to make sure to add that in so that those royal blue lines will be a solid black and that they will be fully defined. So once that tangent is created, we are actually looking very good. And I'm just going to do a box select inside of my sketch and then go under my measure tool and evaluate. And this is going to give me my value of 13,924.58. And that is exactly what we have in the answer key. It is so extremely important that this step be done correctly because the remaining questions reference it. So if this is wrong, we've already failed. That's how it's going to be on the test as well. Now, one thing I want to show you is if I would have tried to actually sketch and create a dimension directly on the sketch lines like this, what you're going to find is if I move this a little bit, that dimension is now also at an angle. That's also why the dimension is not 100, it's 99.85. That is enough to make this sketch incomplete, that the other values for the answers of the questions after this will not be the same. You need to know the difference between that dimension that I just deleted being at an angle and making sure that the angles were orthogonal, which is why I use the planes. The next question is question 3, and we can see here we're going to be adding our weldment profile that we created onto our existing shape. So make sure that the center weldment profile is going to be used, and we're going to use end but one corner treatments to join all segments to each other. And then we'll want the total mass of the part. So I'm going to go under my weldments and I'm going to go under my structural member. Now SOLIDWORKS does a good job of remembering the last profile that you used, so mine was already selected and I'm just creating my first group. Once I've created my first group, remember to apply your corner treatment. So if I zoom in, I can see that the corner treatment's correct and I'm using the center of that weldment profile. I'm going to do a second group, which is going to be the top portion. Now again, always double check your corner treatments because even though N but 1 is selected, I actually need to update that selection so it matches what was provided to us in the image. Because everything was done inside of their groups and inside of a single weldment feature, the trimming has actually been accomplished for us. So I just need to apply my material of 1060 alloy and grab my mass properties. And we can see here that I was at 77,001.15, which again, it matches what is in the answer key. So question 4 is a continuation. Now we're adding the vertical braces into the model. So we're still using the same weldment profile, making sure it's at the center. There's going to be a 0 gap, so there's not going to be a gap that we'll have to add in. So the vertical axis of the weldment profile will be aligned with segment 1, which was what was labeled above, and they are going to be cleanly trimmed. So I'm going to edit my existing weldment feature because I'm just going to add new groups because the profile is the same. Now if I zoom in, I can see it is going into the center, but I actually need to rotate it 90 degrees. So that's something just to be aware of. Make sure your orientation is correct. It won't necessarily affect the mass, but if they do ask you for maybe center of mass, it could be a little bit different. So each of these is going to be its own specific group. Now here under alignment, this is where I'm going to choose basically line 1 from the sketch created or provided to us in the PDF that's going to straighten the weldment profile, and then I can flip the direction. I'm going to do the same thing here, choose a reference line. It's going to help orient the weldment profile, and then I can add 90 degrees to rotate that as well. My material is already applied. All I have to do now is trim some of these specific members. So the 2 items in blue are what are going to get trimmed, and I'm going to trim them relative to some specific faces because I do want the trim to be very, very clean. Now once you have these faces selected, make sure you turn off allow extension. That's going to help really streamline these trims. I can go under my evaluate tab, and then under mass properties we can see that I'm at 94,379, which does match B solution in the answer key. So the last question is question 5, and we're drawing attention to a specific mitered corner with 3 segments going into that particular corner. So we want to make sure that we change the corner treatment and only the vertical leg is what's going to be measured for mass. And it says select only that segment, so only that more vertical portion. So I'm going to right click on my weldment feature and I'm going to go ahead and edit this. Now you can actually come in here and choose a little magenta sphere, and I'm going to add a 2 to the trim order. Notice how that actually does allow those 3 segments to actually be mitered at the same time. That's really as simple as this question is going to be. This is one of those kind of gotcha questions that seems like it should be very, very complicated. But in general, it's going to be pretty quick in how it's done. So from here, I'm actually ready to just grab the mass on that specific body. So I'm going to clear the selection, make sure I'm choosing only that body, and I'm at 4,602.03, which is extremely close to the answer key, I think well within any error parameters provided. That actually brings us to the end of the sample exam. Again, the majority of the work is going to be done in sketching, in 3D sketching, and in possibly creating weldment profiles. Please make sure you are familiar with those. If you have any questions about the 3D sketch that I did or how I set it up, why I set it up the way that I did, please reach out to us at mlc-cad.com. There's also some hints for you inside of the PDF where they kind of explain the same concept with the orthogonal angles. But good luck on your testing, and thank you for your time and attention.